Something strange is happening at the edge of our solar system. A comet, designated 3I Atlas, has been spotted doing something astronomers thought was impossible. It has a jet shooting out in the wrong direction, a backward stream of material that defies everything we know about how comets work. This isn't just a minor anomaly. It's a puzzle that's forcing us to question our fundamental understanding of these celestial wanderers. Could this be a sign of something completely new, or is it evidence of something not natural at all? For decades, the model of a comet has been simple. As it gets closer to the Sun, ice on its surface turns directly into gas, a process called sublimation. This gas, along with dust and rock, is then pushed away by the solar wind and radiation pressure, creating the iconic tail that always points away from the Sun. It's a reliable, predictable cosmic weather vane. But 3I Atlas isn't playing by the rules. It has what astronomers call an anti-tail, and this one is a real head-scratcher. What makes this anti-tail so baffling is its direction. It's not just slightly off-kilter, it's pointed back along the comet's own orbital path. Think of it like this. If the Sun is a giant fan blowing a trail of smoke away from a moving object, this comet somehow has a second trail of smoke blowing straight back from where it just came, as if it's leaving its own wake. This just shouldn't happen. The forces from the Sun are supposed to dominate everything. The fact that this jet exists suggests another, more powerful force is at play, originating from within the comet itself. This has led to some pretty wild theories. Initially, some thought it might be a trick of perspective. Sometimes, when Earth passes through a comet's orbital plane, we can see leftover debris scattered along its path, which can look like a spike pointing toward the Sun. But detailed observations quickly ruled this out. The jet on 3I Atlas is active, continuous, and clearly aligned with the comet's own internal vectors, not with the Sun or our viewing angle. It's a genuine ongoing emission, a feature of the object itself. So, what could cause such a thing? The first clue came from new spectral data. By analyzing the light from the jet, scientists hoped to identify its chemical makeup. They expected to see the usual suspects: water, ice, carbon dioxide, maybe some simple organic molecules. But what they found was different. The composition was unusual, with a higher than expected ratio of certain heavier elements. This suggests the material isn't just surface ice boiling off. It's being ejected from deeper within the comet's core, possibly by a much more energetic process than simple sublimation. This is where things get even more interesting. High-resolution images revealed subtle patterns within the jet, almost like waves or pulses. These rotational patterns suggest the emission isn't random. It's structured and synchronized with the comet's rotation. It's as if a specific spot on the comet's surface is firing off material like a sprinkler head every time it faces a certain direction. This level of structured internal behavior is unprecedented. It hints at a complex internal structure, maybe even geological activity like cryovolcanism, where slushy ice and gas erupt from beneath the surface. But even cryovolcanism doesn't fully explain the backward direction and the sheer energy needed to overcome the solar wind. For that, you'd need a focused, high-velocity propulsion event. This is where the conversation takes a turn, and planetary defense experts have started to take notice. If a comet-like object can generate its own propulsion, it changes how we calculate its trajectory. Our entire system for predicting the paths of near-Earth objects is based on them being passive bodies. Their paths dictated only by gravity and solar forces. An object that can change its own course, even slightly, is a whole new ballgame. It makes predicting potential impacts far more difficult. While 3IATLAS is not on a collision course with Earth, its existence raises a new and worrying possibility. Could there be other objects out there with similar capabilities that we haven't spotted yet? It forces us to reconsider our planetary defense strategies. We may need to start looking not just for passive rocks, but for objects that exhibit active, unpredictable behavior. This brings us to the most provocative question of all. Is this a natural phenomenon we've just never seen before, or could it be something else entirely? The behavior is so precise, so controlled, that it starts to look less like a random outgassing event and more like a deliberate propulsion system. When you have a focused jet of material being expelled in a specific direction, powerful enough to create a visible anti-tail against the solar wind, it starts to check a lot of boxes for artificial technology. Some astronomers, speaking off the record, have admitted that if you were to design a probe to look like a comet for stealthy exploration of a solar system, this is exactly what it might look like. It would use native materials and dust for propellant, and its movements would be subtle, masquerading as natural cometary activity. The structured rotational pulses. They could be course corrections or adjustments. The unusual composition, perhaps the exhaust from a more advanced propulsion system than simple heating. Now, this is, of course, highly speculative. The principle of Occam's razor tells us to prefer the simplest explanation. The most likely answer is that there's a new natural cometary process we don't yet understand. Perhaps some comets have incredibly dense, fast-spinning cores that can sling material backward with centrifugal force. Or maybe there's a bizarre chemical reaction happening deep inside that generates a powerful, focused jet. Science is all about discovering these new, unknown phenomena. However, the more we study 3IATLAS, the more its features seem to defy simple, natural explanations. The combination of a persistent backward jet, its alignment with the comet's own path, the structured pulses, and the unusual composition makes for a compelling and, frankly, unsettling case. It's pushing the boundaries of astrophysics and forcing us to confront the possibility that not everything out there is just rock and ice. This is one of the most exciting mysteries in astronomy today. Scientists around the world are racing to gather more data before 3IATLAS heads back out into deep space beyond the reach of our best telescopes. Every new piece of information could be the key to unlocking this puzzle. Are we witnessing the birth of a new field of comet physics, or are we getting our first glimpse of something far more profound? Something that hints we might not be alone. The universe has a habit of surprising us, but 3I Atlas might just be its biggest surprise yet. What do you think is happening with this mysterious object? Is it a new type of natural wonder, or could it be a sign of technology far beyond our own? Let me know your theories in the comments below. Thanks for watching, and if you enjoyed this journey into the unknown, don't forget to like and subscribe for more deep dives into the mysteries of our cosmos.